Assalamu alaikum. Bismillahirrahmanirrahim. Welcome back to another session of inorganic chemistry. Guys, the topic that I have chosen for today is very important. It is called chemical properties of elements of subgroup 2A. Elements of subgroup 2A are called alkaline earth metals, or they are also recognized as beryllium family. This subgroup, that is subgroup 2A, consists of elements beryllium, magnesium, calcium, strontium, barium and radium. These are all metals and these are all belong to elements of subgroup 2A. Elements of subgroup 2A or 2A of the normal or representative elements are called alkaline earth metals. Chemical properties of these elements includes reaction of these metals with water, reaction with oxygen and nitrogen, and effect of heat on some compounds like carbonates, sulfates, nitrates, and their solubilities, trend in their solubilities. Beryllium has no reaction with water or steam. Magnesium reacts with steam and gives magnesium oxide and hydrogen gas. First element is beryllium. It has no reaction with either liquid H2O or steam, that is vapors H2O. However, magnesium reacts with steam, gaseous form, water vapors, and the product is magnesium oxide plus hydrogen gas. Magnesium oxide is solid. Magnesium metal is solid. So magnesium reacts with steam to give magnesium oxide and hydrogen gas. Similarly, a slight reaction takes place when magnesium ribbon is dipped in cold water. However, the product formed in that case is magnesium hydroxide. That magnesium hydroxide deposits on the surface of magnesium ribbon. Thereby, it becomes difficult for magnesium to further react with the cold water. So in case of reaction of magnesium with liquid water, cold water, the product is magnesium hydroxides, and of course along with magnesium hydroxide, which is solid, you may say slightly soluble, or you generally find in some books as insoluble. This magnesium hydroxide deposits on the surface of the magnesium ribbon and no further reaction takes place. So it forms a barrier on the magnesium, preventing further reaction. Similarly, other elements, calcium, strontium, barium, they react with cold water and their products are the same as that of reaction of magnesium is with liquid or cold water. So calcium, strontium, barium give calcium hydroxide, magnesium, strontium hydroxide, barium hydroxides along with hydrogen gas. You can balance this equation. Now you have 4 hydrogen on this side, 2 plus 2, and 4 on this side, 2 oxygen here, 2 oxygen here. Metals become more and more reactive towards water as we move from top to bottom in a group. General equation has been given in your book, where M represents these metals: magnesium, strontium, barium. These react with water. Product is metal hydroxide, which is solid, and H2O. Hydroxides of lower members are somewhat more soluble than magnesium, so there may be magnesium hydroxide in solid form, whereas there may be calcium or strontium or barium hydroxide in solution form as well. So you may write aqueous as well as solid. Solubility increases, which will become after a short moment. Next, second category. First was with reaction with water. Second category is reaction of the group 2 elements with air or oxygen. Reactions of these alkaline earth metals with air or oxygen. Reactions with air or oxygen. Alkaline earth metals form normal oxide, and you know that in normal oxide, oxidation state of oxygen is -2, -2. And alkaline earth metals have oxidation state +2, so they form simple normal oxide. If alkaline earth metals are represented by symbol M, then their normal oxides would have the formula MO, which these oxides are obtained either by heating metal in oxygen or by heating their carbonates at high temperature. For example, reaction in which is given in your textbook is calcium, which is a solid, which is a metal. It reacts with oxygen and gives normal oxide, calcium oxide. Here oxidation state of oxygen is 2-, and oxidation state of alkaline earth metal is +2, and so oxidation state of calcium is here +2. So calcium oxide is the product. 2 oxygens, 1 oxygen, multiply this with 2, so calcium also 2. 2 moles of calcium react with 1 mole of oxygen gas to give 2 moles of calcium oxide. Similarly, carbonates of these elements, for example calcium carbonate, they are decomposed upon heating into calcium oxide. That is indirect way of preparation of oxide plus O2 gas. Calcium oxide and O2 gas. These are the normal oxides. In addition to normal oxides, elements of group 2A also form peroxides as well. But first of these two, some properties before the discussion on peroxides. We throw some light. We try to understand some properties of normal or simple oxides. In your book, term simple oxide has been used for the normal oxides. Normal oxide are simple oxides. These oxides are extremely stable, white crystalline solids due to their high crystal lattice energy. These are obtained by packing doubly charged cations with the doubly charged anions of oxide, and pattern of packing is just like as packing of ions is in case of sodium chloride lattice. So here lattice energy is high because calcium has +2 charge, oxygen has -2 charge. These are small sized ions, they have high charge density, so their force of attraction is stronger. That's why these oxides are stable. High charge density of oxide, charge -2, and its size atomic ionic radius is small, so it has oxide has high charge density. Same is the case with alkaline earth metals. They have +2 charge as well as somewhat smaller size than their respective alkali metals. So they have high charge density. Oxides have high charge density, so force of attraction is stronger. That's why they are stable. That's why they have high lattice energy. So, second, beryllium oxide. Beryllium is smallest among the elements of group second AB. It consists of only two shells, 1s2, 2s2, and beryllium cation has only one shell, that is 1s2, Pe plus 2. So, magnesium 3 shells, calcium 4 shells, strontium 5, barium 6. Size is increasing, number of shells are increasing, shielding effect is increasing. So, beryllium and magnesium oxides are quite insoluble in water, and they are hard and tough as well because of high charge density. Due to high charge density, these have high lattice energy, and these two oxides are insoluble, beryllium oxide and magnesium oxide. Now, calcium is somewhat bigger in size than magnesium ion, somewhat less charge density. So, calcium oxide and then strontium oxide and finally barium oxide, they even react with water to give soluble hydroxides, which are also strong bases. So, first two oxides are insoluble, calcium oxide and magnesium oxides are beryllium oxide and magnesium oxides are quite insoluble. Calcium, strontium, and barium oxides react with water to give soluble hydroxides, which are strong bases. Except beryllium oxide, all other oxides are basic. Beryllium oxide is, however, amphoteric. That is another example of amphoteric oxide. You know that amphoteric oxides act as an acid as well as a base. So they dissolve in either acids or bases. Beryllium oxide is amphoteric oxide. Remaining oxide from magnesium to calcium, strontium, barium are they are basic oxide. Beryllium oxides is amphoteric, so it reacts both with acids as well as bases. With acid, its reaction is salt, that is beryllium chloride, and other product is of course water neutralization reaction. So you can balance by putting 2 here, this equation. So beryllium chloride plus H2O, this is amphoteric oxide, beryllium oxide reaction with acid. Now this amphoteric oxide reacts with bases as well, for example sodium hydroxide, and the product is sodium brylate, Na2BeO2, sodium brylate. Sometimes you find in some books sodium tetrahydroxobrylate, that is its complete full name and exact or correct name. But for simplicity, you can write in this way too: sodium brylate, Na2BeO2. If you do not put hydroxide here, then you will have to write water as well, H2O as well as another product. You can balance it. Here to have 2 sodium, you will have to put value 2 here, and now you have hydroxides, sodium 2 and sodium 2 here, and in this way you can 2 oxygen here, 1 oxygen here, 3, 2 oxygen here, 1 oxygen, 3, 2 hydrogen here, 2 hydrogen here. In your textbook there is 2 put in this equation. There is present 2 here, so you need not to write that, and your equation is balanced now. Beryllium 1, sodium 2, oxygen 2 and 1, 3, oxygen 2 and 1, 3, hydrogen 2 and 2 into 1, 2 hydrogen. So that is the oxides of other metals are basic in character. So sodium brylate, that is a salt, beryllium chloride, that is a salt, plus water neutralization. Beryllium oxide is an amphoteric oxide. It reacts both with acids as well as bases. It dissolves in both acids as well as bases. So beryllium oxide, beryllium hydroxide or beryllium metal, they show amphoteric properties here. Due to small size of beryllium ion, beryllium oxide is covalent Be plus 2. You know that electronic configuration of Bs2, 4 protons here, 1 s2 only. In case of beryllium atom, you have 1 s2 and 2 s2. So when beryllium atom loses these two electrons, it means no more second shell is present, no more electron is present in the second shell. Now first shell, that is 1, and it comprises only subshell S, which consists of only one orbital, that is S. Now this S orbital is attracted by 4 protons. There is no intervening shell between this 1s electron, between these 1s electrons and protons of the nucleus. So strong attraction pulls this 1s orbital closer, and as a result size of beryllium ion is decreased, and as a result of which high charge density it will acquire. Due to high charge density, it attracts shared electron pairs with oxide, and due to this it acquires somewhat covalent character. So due to small size of beryllium ion, beryllium oxide is covalent with, while the other oxides are ionic. Rest of the oxides are ionic: magnesium, calcium, strontium and barium, because charge density is decreasing. So these are the properties of the simple oxides. Simple oxides are formed by the reaction of these metals with air or oxygen, and or by decomposing some of its compounds. In this particular book, only carbonate has been discussed. Thermal decomposition, that is by heating, we get normal oxide. This reaction is written here. By heating, we get calcium oxide. We can obtain oxide from other compounds as well, but since they have not been mentioned in your book, you need to discuss that here. And properties: they are stable crystalline solids. Their solubilities: beryllium and magnesium are insoluble, rest are soluble, and solubility increases down the group. Third, beryllium oxide is amphoteric. Rest of the oxides of elements of group 2 are basic. Due to small size, oxides of beryllium develop covalent characters. Rest of the oxides have ionic character. Oxides of beryllium has high melting point, harder than oxides of other metals. Each beryllium atom, since in case of beryllium ion, it has second shell that is completely free from electrons. No electrons are present. Here we have 2s, 2px, 2py, 2pz. So these orbitals 2s, 2px, 2py, 2pz, they can coordinate with oxygen of the other compounds and or oxides and form coordinate covalent bonds. So beryllium ion is tetrahedrally linked with 4 oxides in crystal lattice. That's why its coordination number is 4, due to availability of 4 orbitals in the second shell which are not occupied by electron. So they provide a place to accept, to coordinate or to link through coordinate covalent bonds with some other oxides, and due to which its shape is just like tetrahedral. At angle of atoms are at angle of 109.5 degree. Second topic is peroxides. In your previous group study, that is elements of group 1a, you found peroxides of sodium. In peroxide, oxidation state is O2 minus 2. Alkali metals have oxidation state M plus 2. So their general formula would be MO2. Here it is not minus 4 of 2 oxygens. It is O2. Peroxide has oxidation number -1 of single oxygen. O2 -2. M +2. So this is the formula of peroxides of journal. Peroxides of heavier metals, calcium, strontium, barium, lower members which have more mass, so that's why they are called heavier metals, can be obtained on heating their normal oxides with oxygen at high temperature. Normal oxides are formed by reaction with oxygen, and if you heat further with excess oxygen, ultimate result is the barium peroxide, BaO2. So we can balance here, oxygen 2 and 2 4, so multiply 2, barium 2, oxygen 2 and 2 4, barium peroxides. Similarly, you can find other peroxides as well. Now, some properties of peroxides. These peroxides are white ionic solids having peroxide anion O-2. I have already told you peroxide है O-2. They react with acids to produce hydrogen peroxide. For example, this peroxide, it further reacts with some acid like HCl or H2SO4. In your book example is given H2SO4, same as I am reproducing here. So product was be barium sulfate. Now sulfate from here, and O2 - 2 peroxide will be replaced by sulfate in this case, and it will become part of the hydrogen, and the second product would be hydrogen peroxide. Sulfate SO4 - 2, O2 - 2, H2O2 hydrogen peroxide, barium sulfate, and barium sulfate is a solid, and second product is hydrogen peroxide, H2O2. So they react with acids, these peroxides react with acids, and as a result salt and peroxides are formed. Now, third property, reaction of alkaline earth metals with nitrogen. Keep in mind that during the discussion of alkali metals or elements of group 1A, there was no such reactions, because in that case only lithium reacts with nitrogen to give lithium nitride, but here all alkaline earth metals react with nitrogen to form nitride. You should understand the difference between nitride, among the nitride, nitrate, etc. Nitride is N-3. So all elements means alkaline earth metals, calcium, strontium, barium, etc., magnesium, burn in nitrogen to form their respective nitride. For example, here a reaction as an example is quoted, reaction of calcium with nitrogen. Nitrogen, you know, has triple bond and high energy. It is not very much reactive. So CaN, N-3, Ca +2, you place 2 here and -3, 3 here. That is calcium nitride. So calcium, nitrogen is 2, nitrogen is 2 on both sides, whereas calcium is 3 and calcium is 3 here, calcium nitride. Similarly, you can write other reactions of other alkaline metals with nitrogen. Just you are to replace calcium with other metal. For example, in case of magnesium, you will place magnesium here. Ultimate product will be magnesium nitride. You are pronounce it as nitride, 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 magnesium nitride. There are some reaction of nitride has been given its reaction with water. When this calcium nitride reacts with water, we get ammonia gas. That is a preparation as simple in a small volume of ammonia gas from calcium nitride. Calcium nitride on reaction with water liberates ammonia gas. So this calcium nitride reacts with water. One product is of course calcium hydroxide, and the other product would be ammonia gas. Calcium hydroxide and ammonia gas. You have 3 calciums here. You can balance by placing 3 here, and after that you have nitrogen. In this case there are 2 nitrogens, Well, in case there is one nitrogen, you can place 2 here to balance the nitrogen as well. So if you are to balance this one, you are to balance this one too. Hydrogen 2 into 3, 6, 6 and 3 into 2, 6, 12. So you put 6 here and this equation is balanced now. So in case of magnesium nitride, you will get here magnesium hydroxides and ammonia gas. Beryllium nitride is volatile, while other nitrates are not so. The beryllium nitride has lower boiling point, so that's why it is volatile. It this effect may be traced through its reaction with through its electronegativity difference between beryllium and nitrogen. In case of electronegativity, you have studied that electronegativity go on decreasing as we are moving from top to bottom. So beryllium has highest electronegativity among the elements of group 2A, and so beryllium has highest electronegativity among themselves, and nitrogen also has electronegativity that is somewhat higher, but due to small electronegativity difference between beryllium and nitrogen, this compound is comparatively less polar and with respect to rest of nitrides of this group. So beryllium nitride is having somewhat weaker forces, is more volatile as compared to nitrides of the other alkali metals, alkaline earth metal elements of group A. Thank you so much. In our next lecture, we shall try to understand something further about compounds of this group, solubility of hydroxides, and effect of heat on some compounds, sulfates, carbonates, nitrates, etc. Thank you so much. Pakistan Zindabad.